Brian Odongo, and ready to have this session with you learners. And today we are going to have a discussion in a Form 3 topic, matrices, and the subtopic of the day should be solving simultaneous equations using matrices. Solving simultaneous equations using matrices. So learners, I welcome you all here. Let's have the session solving simultaneous equations using matrices. Solving simultaneous equations. Solving simultaneous equations using matrices. Solving simultaneous equations using matrices. So learners, that is what I want to discuss today, solving simultaneous equations using matrices. And before we dive into that discussion, learners, it's very good to have a recap of what we need to know before setting off. So having said that, let's look at the objectives, our learning objectives of the day. Let's look at our learning objectives of the day, that by the end of this lesson, you should be able to 1. Define a matrix and its order. You should be able to define a matrix and its order. 2. Represent simultaneous equations using matrices. Represent simultaneous equations using matrices. And finally, solve equations using inverse matrices. Solve equations using inverse matrices. Let's look at what a matrix is. What is a matrix, learners? First of all, let's start by defining a matrix. Learners, when we are defining a matrix, learners, we all know that this is just a rectangular arrangement of numbers in rows and columns. A matrix is simply a rectangular arrangement of numbers in rows and columns. For example, if I have numbers, for example, I have 18, I have 19, I have 50, I have 97. Learners, this one here is called a matrix. Why do we call it a matrix? Learners? Why do we call it a matrix? It's simply because it's an arrangement of numbers in rows and columns. And we do wrap them in squares. So basically that's what a matrix is. It's just a recap of what you need to know to be very fine with this session. Also, let's look at what is called the order of the matrix. Order of the matrix. Let's see the order of the matrix, learners. When we talk about the order of the matrix, in what order do we say a matrix is? Or how do we define the order of a matrix? Yes, the order of a matrix is defined by taking rows times columns, learners. That's how we define the order of a matrix. You look at your matrix, look at how many rows does your matrix have. Then look at how many columns does it have. Then the order of the rows and columns gives you the order of a matrix. So the order of the matrix, learners, is normally given by rows times columns. Rows times columns. That's how we define the order of a matrix, by taking rows times columns, dear learners. For example, look at this matrix I've written here. How many rows do you think are there? Yes, we have 2 rows in this matrix because this is the first row and this is the second row. So the number of rows are 2, What about the columns in this matrix that I've written here? How many columns are there? Excellent learners. We have 2 columns here. These are one column, this is another column. So that's 2 columns. So how do we define that, the order of this matrix? That matrix, we call it it's a matrix of 2 by 2. Its order is a 2 by 2 matrix. It's a 2 by 2 matrix because it's made up of 2 rows and 2 columns. Very nice. How do we represent equations as matrices? We're going to representing equations as matrices, learners. Representing equations as matrices. Let's look at this example. Let's look at this example. I'm having an equation of the type 2x plus 3y. I'm having 2x plus 3y should be equal to 12. 2x plus 3y should be equal to 12. Another equation I'm having is 4x minus y. 4x minus y being equals to 3. 4x minus y being equals to 3. Those equations we are having there are called linear equations. They are called linear equations because if you rewrite them, you will find them obeying the rule of y is equals to mx plus c. Now, how can we change those equations into what we call matrix equations? How to represent linear equations in matrix equation? I want to change these linear equations onto what we call the matrix equations. We change them into what is called the matrix equations, learners. And there are some steps we need to follow keenly if we need to write it in a matrix equation. Step number 1, check on how the unknowns have been arranged. Check on how the unknowns have been arranged. When we talk about the unknowns, learners, we are simply referring to the x and the y. We are simply referring to the x and the y. Look at the order. If you look at my two equations keenly, the first equation is beginning with x, then y. The second equation is also repeating the same, x followed by y. So what do I mean by saying that? In step 1, you have to check the unknown equations, how they are being arranged. Look at your unknown equations. They are all starting with x, then followed with the unknown, which is y. So if that step number 1 is satisfied, learners, you are now free to proceed into step number 2. You are now allowed to proceed into step number 2. Let's look at step number 2. Make the coefficients of unknowns to be on one matrix, comma, unknowns on their matrix 2 and the constants on their matrix 2. Learners, I want to be together there. Let's look at our matrix, our equations. What if you look at the first equation, the coefficient of x in the first equation is 2, so you have to put the 2 there. The coefficient of y on the first equation is 3. Then we come to the second equation. The coefficient of x in the first equation, learners, is 4. You put there 4. Then the coefficient of y in the second equation is -1. You put the -1 there. So those are the coefficients. So step number 2 simply says, make sure that the coefficients are in one matrix. So these coefficients, we wrap them in one matrix, like that. I've wrapped my coefficients in one matrix. After wrapping now my coefficients, learners, in one matrix, after wrapping the coefficients in one matrix, we also say, also put the unknowns on their matrix too. These unknowns, my unknowns are the x and y. Because we are starting with x then y, then we are going to write it in such a manner it is x then y, like that. They should also be in their own matrix. Then after that, obviously we have an equal sign. Then these constants, the constants, that is the 12 and the 3, you also wrap them in their own matrix. You also wrap them in their own matrix. When you wrap them in their own matrix, that is 12, then 3. This is step number 2. We are going stepwise so that we understand exactly what is required of us, dear learners. Thank you. After satisfying step number 2, we've written it like this. Now this is what is called a matrix equation. I've seen questions in an exam, you're given statements, then you are told, can you write a matrix equation? That is how you write a matrix equation. Get to know the difference between linear equations and matrix equations, dear learners. Get to know the difference. Thank you. Let's look at, after getting to know that, I want to get to know, if you have a matrix, I want to learn on how to get the determinant of the matrix. All these steps I'm following will make our work easier when we go into solving simultaneous equations by matrix method. We'll have to follow all these steps. So having a recap of these steps, learners, is very, very important. And we will appreciate it when we start solving simultaneous equations. So let's get the determinant of the matrix. Determinant of matrix. Let's get, learners, the determinant of the matrix. Determinant of a matrix. Learners, when we talk about the determinant of a matrix, what do we simply mean? We are referring to the difference between the product of elements in the main diagonal and the product of elements in the minor diagonal. The determinant of a matrix is the difference between the product of elements in the main diagonal and the product of elements in the minor diagonal, as shown there clearly. Determinant is the product of elements in the main diagonal minus the product of elements in the minor diagonal. Look at how I identified my main diagonal and my minor diagonal. Look at how I identified my main diagonal and my minor diagonal. The main diagonal, learners, if you look at the diagram I've drawn very well, the matrix, sorry, I've represented very well there on the border. My main diagonal is the one that is running from the top left to the bottom right. From the top left to the bottom right, that gives you the main or the leading diagonal. Then the one running from the bottom left to the top right, that one is called the minor or the secondary diagonal. That is called the minor or the secondary diagonal. So determinant, you simply take the product of elements in the main diagonal minus the product of elements in the minor diagonal. Because learners have said that the main diagonal is the one running from the top left to the bottom right. Then look at the elements there. In the main diagonal, I'm having the elements as 2 and -1. While in my minor diagonal, learners, if you look at it keenly, I'm having the elements as 3 and 4. So in order to get the determinant of the matrix, I'm going to take the product of the values in the main diagonal, that is 2 times -1, I minus the product of elements in the minor diagonal, that is 4 times 3. What is 2 times -1, learners? If you take 2 times -1, the answer should be -2. Then we ask ourselves again, what is 4 times 3? Confirm in your calculators, dear learners, 4 times 3. Wonderful. 4 times 3 is 12. Now we are having -2 minus 12. What do you get? -2 minus 12. It's just like you have a date of 2 people. Person A, you've got that person's date of 2 shillings, and another one you've got the person's date of 12 shillings. So in total, you've got a date of how much? 14 shillings. So -2 minus -12, you are going to get -14. And that -14 you've gotten is, learners, what we call the determinant of the matrix. Don't forget, determinant of the matrix is obtained by taking the product of elements in the main diagonal minus the product of elements in the minor diagonal. Thank you. After we've gotten that, I want now, because we've now gotten that our determinant has been 2 times -1 minus 4 times 3, and we've gotten the determinant here as -14. Let's now see on how we can get the inverse of the determinant. The inverse of the matrix, sorry, should be the inverse of the matrix. To get the inverse of the matrix, there is something that happens. The inverse of the matrix is normally obtained by taking 1 over the determinant. Then I want to take note on what happens to the values. The values in the main diagonal interchange positions. My main diagonal was 2 and -1. So the 2 and -1 interchange the position. -1 goes on top, 2 comes at the bottom. That is step number 1. The values in the main diagonal interchange the position. Then the elements in the minor diagonal negate. We negate those elements or we change their signs. If the element in the minor diagonal was negative, it becomes positive, and vice versa. And vice versa. So if you look at it, you realize, it is now -4, -3. We negate the elements. So this can be written as your determinant is now -1 over 14 into -1, -4, -3, 2. Wonderful. And by doing it like that, learners, you would have gotten the determinant of the matrix. You would have gotten the inverse. So I've said first start by getting the determinant. Main diagonal, my values, product of elements in the main diagonal minus the product of elements in the minor diagonal. After getting the determinant, to get now your inverse, take 1 over the determinant, multiply it, interchange the position of elements in the main diagonal, interchange, swap them. Then in the minor diagonal, change the sign. If the element in the minor diagonal was a negative number, make it to be a positive number. And if it was a positive number, make it to be a negative number. Wonderful. Let's now get into solving using the inverse matrix. Solving equations using the inverse matrix. We are going to use the formula. When we want to talk about solving equations using the inverse matrix. This is the formula we are going to use. Remember, we want now to check on solving using inverse matrix. Solving using inverse matrix. Learners, we are learning about solving equations using the inverse matrix. And I've already shown you how to get the inverse of a matrix. So the steps I showed you earlier are very, very important. So we are going to have the formula x should be equal to a raised to power -1. That is the inverse of a times b. That is how we are going to work it out. That's how we are going to work it out. So first of all, they say, step number 1, find the inverse of the matrix. Find the inverse of the matrix. I think by now you know how to get the inverse of the matrix. After finding the inverse of the matrix A, step number 2, multiply A inverse by B, or pre-multiply the inverse of the matrix to B. I'm going to show you what the A, the B, and the X are with an aid of an example. Then the result is the solution for X and Y. Okay? Find the inverse of matrix A, multiply the inverse of that matrix by B, then the result is the solution for X and Y. Let's get into an example 1. Let's get to our example 1. Let's get into our example 1. And we are going to work it, learners, step by step. Going to work it step by step. Solve 3x plus y should be equal to 7 and 2x minus y should be equal to 1. We are told to solve using matrix method. We've been given two simultaneous equations. 2x plus y. 2x plus y to give us 7. 2x plus y to give us 7. The next equation we are having is 2x minus y to give you 1. And you are told solve the equations using matrices. What do we do? This is a system of linear equations. Step number 1, you change the linear equations into matrix equations. Learners, we began by discussing it like that. You change the linear equations into matrix equations. And how do you change the linear equations, learners, into matrix equations? It's very simple. Pick your first, before you do the changing, confirm your constants, the order in which the constants are. The variables, the x are all in one line, in one column, that's very correct. Y's are always in one line, that's very correct. Then all my constants are on the other side of the equal sign. Very correct. After that confirmation, I can now put the coefficients on one matrix. The coefficients here for equation 1, the coefficients will be 2, 1. For equation 2, its coefficients is 2 and negative 1, like that, dear learners. You wrap these in one matrix like that. You wrap it in one matrix like that, dear learners. Then your unknowns, you also put them in one matrix based on the procedure I gave before. So x followed by y, like that. This should be equals, also these constants, you wrap them in one matrix. These constants, we wrap them in one matrix like that. After wrapping, there's a formula written on top here that x is equals to A inverse times B. So if you have it, if we have it like that, if we are having this as our matrix equation, the first matrix here, learners, this first matrix here is our matrix A. Then this matrix that is having the unknowns is our matrix X. Then this matrix that is having the constants on the other side of the equal sign is our matrix B. Are we there, learners? Now, having that, let's look at this. They are saying x is equals to A inverse times B. What do they mean? First of all, let's get the inverse of matrix A. Learners, do you remember how to get the inverse of matrix A? Wonderful. You people tend to remember. So let's get the A inverse. Before we get the A inverse, what should be the first step when you want to get the inverse of the matrix? What is the first step to get in order to get the inverse of a matrix? That is awesome. The first step is to get what is called the determinant of A. How do you get the determinant of a matrix? We said the determinant of a matrix is simply obtained by taking the product of the values in the main diagonal. Let's look at this matrix A here. What is our main diagonal? Our main diagonal is the one having values 2 and negative 1. Okay, let's get the product of elements in the main diagonal. That is 2 times negative 1. 2 times negative 1. After getting the product of elements in the main diagonal, we are going to subtract the product of elements in the minor diagonal. What are the product of elements in our minor diagonal? 2 times 1. That is 2 times 1. Learners, what is 2 times negative 1? What is 2 times negative 1, learners? That is 2 times negative 1 is negative 2 minus 2 times 1 is 2. So negative 2 minus 2. What do you get, learners? When you take negative 2 minus 2, excellent. Negative 2 minus 2 is negative 4. So the determinant of our matrix, learners, is negative 4. Are we there? Very nice. After getting the determinant as negative 4, let us now get the inverse of A. A inverse. The inverse of a matrix which is represented by this. This means that the inverse of that matrix is simply obtained by taking 1 over the determinant. What is our determinant? Our determinant we've gotten as negative 4. 1 over negative 4. You multiply it. What happens to the elements, learners? There's something I said. When you're getting it, the values of the main diagonal interchange positions. They switch the positions. The values in the main diagonal switch the positions. So when they switch the positions, that will now be, when they switch the positions, negative 1 and 2 will switch the positions. And what are we going to have? We are going to have negative 1 coming on top, then 2 coming at the lower row. So negative 1 and 2 have switched the positions. Then what happens to the values on the main diagonal? The values in the main diagonal, change the sign. If it's positive, it becomes negative and vice versa. So you see here, this 2 was positive, so it will become negative 2. This one here was positive, it will become negative 1. And that is the inverse of that matrix. In fact, even you can leave it at that point, it's still correct, or even you can work it better further, because you know, when you have negative 1 over 4, you multiply it by this, it means negative 1 over 4 is going to multiply every element that is inside the matrix. So negative 1 over 4 times negative 1, that will become 1 over 4. Negative 1 over 4 times this negative 1 also here will be negative, so this will be 1 over 4, because a negative and a negative becomes positive. Negative 1 over 4 learners times negative 2, that will become 2 over 4. Then negative 1 over 4 times these 2 will become negative 2 over 4. Now I'm done with that. After I've gotten my inverse matrix, step number 3 was, can you pre-multiply the inverse of the matrix on both sides of the equation? Remember, on the left hand, they say pre-multiply, learners. You pre-multiply the inverse of the matrix on both sides of the equal sign. To pre, what do you understand by the term to pre-multiply? Pre means before, right? It means start with your inverse matrix, then you proceed. So on the left hand side, instead of starting with this matrix A, I'm first going to start with my inverse of the matrix. That is 1 over 4, 2 over 4. Then on the next column we have 1 over 4, negative 2 over 4. Now this inverse of my matrix, I'm going to pre-multiply it with what is on the left hand side, that was 2, 2, 1, negative 1, xy, like that. Are we there, learners? You pre-multiply the inverse of the matrix on both sides of the matrix. So I've pre-multiplied on the left hand side. This should be equal to, I'm also going to pre-multiply this inverse of the matrix on the right hand side of my equal sign. On the right hand side, remember I have 7, 1. But before the 7, 1, I'm going to pre-multiply the inverse of the matrix. That will become learners, that will become 1 over 4, 2 over 4. 1 over 4, negative 2 over 4. This is my inverse matrix, learners. After getting this as my inverse matrix, I'm going to pre-multiply it with this element, which is 7, 1. Are we there? Then there is something, learners, that you need to remember. What do you need to remember, learners? The inverse of the matrix times the matrix itself gives what you call an identity matrix. Inverse of the matrix. Inverse of the matrix. You multiply this by the matrix itself. It always gives you what is called an identity matrix. An identity matrix, don't forget that. Okay? So what do I mean? If I take the inverse of the matrix, which is A inverse, I multiply it by the matrix A, I'm going to get an identity matrix. What is an identity matrix? An identity matrix is a matrix that has ones on the main diagonal and zeros on the minor diagonal. So my main diagonal will have 1, 1, my minor diagonal will have 0, 0. An identity matrix is in the form of 1, 0, 0, 1. This is a rule. Even if you do the multiplication, obviously it will come here. Knowing that it means when you multiply this inverse of the matrix times its matrix itself, I'm going to get 1 0 0 1. Now times my xy. Okay, that should now give you what you are doing here. Now, how do you multiply matrices? Learners, when you want to multiply matrices, we normally multiply row times column. That is the rule. When you're multiplying matrices, learners, always multiply rows times column. I want to do this multiplication together. So, how am I going to achieve this? I'm going to do it in this manner. 1 over 4 times 7, it's row times column. Don't forget that, learners. Row times column. So 1 over 4 times 7, you add it to 1 over 4 times 1. That gives you the value. With the help of our calculators, let's do it together. Let's do it together. Get your calculator ready. I'm also having mine here. 1 over 4, you key in 1 over 4. You multiply it by 7. You close the bracket because you opened before doing it. Then key in addition sign. Open another bracket, learners. Then 1 over 4. Remember, we are doing 1 over 4 times 7. Plus now this 1 over 4 times 1. Plus 1 over 4 times 1. Times 1. What are you getting? I'm getting that value as 2, row times column. So it means this value here is 2. When I do row times column by summation, I'm going to get this value as 2. Nice. I also do the second row. The second value is row times still the same column. So 2 over 4 times 7 plus negative 2 over 4 times 1. I will use my calculator again, dear learners. I will use my calculator here again, dear learners. I'll use my calculator. That will be now 2 over 4. 2 over 4 times 7. Close the bracket. Plus negative 2 over 4. Plus negative 2 over 4. Negative 2 over 4 times 1. I'm getting the value as 3. I'm getting this value as 3. Learners, after I've gotten that, there is also another rule you should know, that when you take an identity matrix times any matrix, you are going to get the matrix itself. So when I take an identity matrix, I take identity matrix times any matrix, I should be getting the same matrix. I should be getting the same matrix. I should be getting the same matrix. So when I multiply these values on the right hand side, I'm still going to get x, y being equal to 2, 3. Being equals to 2, 3, like that. So this simply means the value for x is 2 and the value for y is 3. The value for x is 2 and the value for y is 3. And by doing it like that, learners, you would have solved the equations using matrix method. You would have solved the equations using matrix method. Anyone with a question on example 1, learners? Anyone with a question? If there is nobody with a question, let's dive into example 2. Let's dive into example 2 and we try it together. Let's dive into example 2 and try it together. Let's get into example 2, learners, which is our second last example, and try it together. Learners, we should enjoy solving simultaneous equations by matrix method because it's one of the easiest method. And remember, this subtopic is so examinable. And it's also applicable, not only examinable, but applicable in real life scenarios in many ways, which I'll tell you as we approach towards the end of the session. Solve the following using matrix method. We were given solve the following using matrix method. And what we were given was 5y plus 4x. 5y. This is example 2. That is example 2. It's there. Example 2. Example 2. Let's check on example 2. Not example 3. Let's check on example 2. Let us check on example 2. Use matrix method to solve. Use matrix method. Use matrix method to solve. To solve, we've been given from what is being projected. You can see we have 5x plus 3y. 5x plus 3y should be equal to negative 26. 5x plus 3y should be equal to negative 26. Then 3x minus 4y should give you negative 33. Should give you negative 33, learners. We need to solve the equations using matrix method. We need to solve the equations, learners, using matrix method. Let's enjoy solving it, learners. Step number 1, cross-check your constants and see if the x's and the y's are in the same order, because sometimes you may find some equations they've interchanged. If I cross-check x, y, then constants, then step 1 has been met. I now go to step number 2. With step number 2, group the coefficients, the unknowns on one matrix, the coefficients of the unknowns, that is 5, 3, 3, negative 4. Then the unknowns also on another matrix, that is x, y, in that order, should be equals to then also your constants, you put them, that is negative 26, negative 33. Negative 26, negative 33. With this one now we are going to move quite fast. Step number next, what are we going to do? First get the determinant of this matrix. We get the determinant of our matrix. And to get the determinant, what did we say, learners? Determinant is obtained by taking the product of elements in the main diagonal. What are our elements in the main diagonal? The elements in our main diagonal is 5 and negative 4. So that is going to be 5 times negative 4, the product of elements in the main diagonal. We are going to subtract the product of elements in the minor diagonal. Elements in the minor diagonal, we have 3 and 3. So their product is 3 times 3. Like that. Excellent. So what is 5 times negative 4, learners? What is 5 times negative 4? Thank you. 5 times negative 4 is negative 20. You minus, what is 3 times 3? Yes, 3 times 3 we get 9. So we ask ourselves, negative 20 minus 9. What do you get? Negative 20 minus 9, you are going to get negative 29. Negative 29, like that. So that negative 21 we've gotten, negative 29 we've gotten, is what we call the determinant of the matrix. Don't forget. That one is the determinant of the matrix. After getting the determinant of the matrix, we are going to get the inverse of the matrix now. And to get the inverse of the matrix, it's still simple, learners. To get the inverse of our matrix, what are we going to do? The inverse of our matrix, you simply take, let me write on top here so that we can all see it. To get the inverse of the matrix, which is maybe A inverse, you take 1 over the determinant. What is our determinant? Our determinant is negative 29. You multiply it by, be very keen, the values in the main diagonal interchange their positions. So we had 5 on top, negative 4 at the bottom. We are going to swap their positions such that the position of 5 is being taken by negative 4. Then the position of negative 4 at the bottom here is being taken by 5. I've swapped the position of elements in the main diagonal. What about the elements in the minor diagonal? We negate those elements. If it was positive, we make them negative, and if it is negative, we make them positive. So here I'm seeing 3 is positive, so we make it to be negative. And at the top, again, I'm having 3 positive, so we make it negative. Learners, that is the inverse of that matrix. That is the inverse of that matrix. I've told you, if you in an exam you are asked to get the inverse of a matrix, if you leave it like this, you are still correct. But if you still find like you've got time and you trust yourself a lot, you can work it further by multiplying it out, by opening the brackets. 1 over negative 29 times 4, we are going to get, that is 4 over 29. Because negative times a negative number becomes a positive number. Then 1 over negative 29 times 3, sorry, times negative 3, we are going to get 3 over 29. On this other column, it will be 1 over negative 29 times negative 3, it will become 3 over 29. Then at the bottom here, 1 over negative 29 times 5, that will become negative 5 over 29. Learners, be very key. Now that is negative 5. Because a negative number times a positive number becomes a negative number. Now, this is still our inverse. After getting the inverse of our matrix, what we have, learners, after getting the inverse of our matrix, you pre-multiply the inverse of the matrix on both sides of your equation. So on this side of the equation, before you pre-multiply, pre means start with the inverse first. So that is 4 over 29, then 3 over 29, 3 over 29, negative 5 over 29. When you pre-multiply it, on that side we had, we used to have 5, 3, 3 negative 4, in form of xy, you are going to get still the inverse of the matrix pre-multiplied on this side, that is 4 over 29. Then this will be 3 over 29. 3 over 29, negative 5 over 29. You pre-multiply this inverse by the constants on this side, which we have is negative 26, negative 33. Now, when you pre-multiply, the inverse of the matrix times the matrix itself becomes an identity matrix in the form of 1, 0, 0, 1. 1, 0, 0, 1. An identity matrix always. Then this is xy. Let's multiply also this other side. Multiplication is always row times column. Don't forget that, learners. Row times column with the aid of our calculators. The first value I'm having is 4 over 29 times negative 26. 4. So you open your brackets, then you key in 4 over 29. You multiply it by negative 26. You multiply it by negative 26. You close your bracket. Then you press add. Then open another bracket. Now it will be row times column. 3 over 29 times negative 33. 3 over 29. You multiply it by negative 33. You multiply it by negative 33. You are going to get negative 7. Negative 7. Negative 7. Then you do the same on the second row. Row times column still. So that will be, open your bracket, key in 3 over 29. Key in 3 over 29. You multiply it by negative 26. You multiply it by negative 26. Then you close the bracket. Then you open another one plus. Now this is negative 5 over 29. Don't forget that. Negative 5 over 29. Negative 5 over 29. Negative 5 over 29. You multiply it by negative 33. You are going to get it as 3. That is positive 3. You are going to get this as positive 3, learners. Then this one you wrap here. And once you do it like this, remember there is a law I've written there. The identity matrix times the matrix itself becomes the matrix. So this one is just like saying x is equals to negative 7. Y will be equals to 3. And you'll have solved that by matrix method. Why am I insisting on pre-multiplying the inverse of the matrix by the matrix? Sorry, pre-multiplying the inverse of the matrix on both sides. Remember in matrices, remember this rule that A times B is not equal to B times A. Please remember that rule. A times B in matrices is not equal to B times A. Is not equal to B times A. The common mistakes that a learner can easily make in this subtopic, the common mistakes to avoid. We have some common mistakes to avoid. Number one, mixing up the matrix order. That is the rows versus the columns. Make sure you don't mix up the rows and the columns. Mistake number two, using the wrong matrix for inverse. Make sure you are using the correct matrix. Get 1 over determinant, interchange the position of values in the main diagonal, then negate the values in the minor diagonal. Then multiplying in the wrong order. And I've written that there clearly. A inverse times B, not B times A inverse. What do I mean? When I take A inverse times B and someone else takes B times A inverse, we will get different answers. That's why we normally talk of it as pre-multiplying the inverse of the matrix on both sides. Another common mistake to avoid, forgetting to check if the determinant is not equals to 0. Forgetting to check if the determinant is not equal to 0. Forgetting to check if the determinant is not equal to 0. Let's have the final recap on what we learned today. Let's have a recap on what we learned today. The recap on what we learned today. You will learn that 1, we learned on how to write equations in such that A times X should be equals to B. We write equations in form of A times X should give you B. A was our coefficients, X was our unknowns, then B were our constants. Then we've also learned on how to get the inverse of a matrix, that is A inverse. Then finally we've learned that to get the unknowns, you simply pre-multiply the inverse of a matrix times your constants on the other side. That gives you the solution. Learners, every matrix you conquer sharpens your mind for the next challenge. Every matrix you conquer always sharpens your mind for the next challenge. Thank you for joining this session. But before I leave, I have some practice questions for you. Before I leave, I've got some practice questions for you so that you can go try them on your own and see how better you understand the session. How better you understand the session. The first question is x plus 2y equals to 10. Then the next equation is 3x minus y equals to 5. Kindly please go attempt to get the values for x and the values for y. Then question number 2, we have 2x plus 3y being equals to 12 and 4x minus y being equals to 3. 4x minus y being equals to 3. So go try solve those two equations using matrix method. Enjoy it with your friends. Teach those who've not been able to attend them and advise them to join this channel always for math sessions. Thank you. Let's meet next time.